Welcome everybody. This is the Society of Amateur Radio Astronomers Radio Telescope Observation Party. The purpose of an observation party is to concentrate a little more on how to observe, what to observe, as opposed to the strict technical engineering to develop your telescopes and everything else, even though we allow all of that. But if you've got any observations, this is a good time to put it in. We do record this, and we'll put parts or all of it on YouTube. If you guys haven't seen our YouTube channel, we've got a lot of instructive and informative videos on YouTube. And if you want to get really technical, we've got a journal called Radio Astronomy that we publish every 2 months. And that contains very detailed explanations of theory and everything like that on radio astronomy. Okay, a little bit about what's going on this year. We do have the Western Conference, which will be in Dallas, University of Texas at Dallas, on 8th to 9th April. It coincides with the eclipse. It will be a full, you'll get the full eclipse in Dallas at that time. So anybody, you can join virtually or actually go there. So if you want to do that, just go ahead and go to the website and sign in. A couple of things have happened. We did get the we did get published in the ARRL antenna book, and if you look at it, we got a lot of the SARA members were authors on that. It was under the antenna section for receive-only antennas for radio astronomy, and that was the first ever they've done in the antenna book, and this was the 50th year anniversary on it. So we've also been asked numerous times now to do the full engineering book, and so right now I'm in contact with them. I'm going to put out give them a draft sort of a table of contents. They want to understand our receiver systems as opposed to our antennas. We already got our antennas sort of covered. Now they want to understand our receiver systems. How do we get these very minute signals in our receivers, and how do we do all that? And so anybody that's interested in providing some data on how to use our receivers for radio astronomy, let me know. We're going to see if we can get, I'm going to pull together a bunch of the journal articles and contact authors that looks like it's applicable. The first draft is due in March. And just like last year, it took a full year. I think it was from December to December for the, from when we submitted the full final to when it actually got published. So very long process, but it pays off in the end. We got a lot of professional authors now. And we got a couple bucks for our articles. So that's good. Okay. What else has happened? We're going to congratulate Wolfgang on his excellent FRB article that they put in. If anybody hasn't seen that, he put the link on listserv. And congratulations, Wolfgang, and your whole team for that. Let's see. We did put out a new index. I finally got went back to all the different conferences and everything this year and updated the index. I put that on listserv. It'll go up on the website pretty soon. But we managed to put together 128 articles and videos in 2023, which is a large amount of content, and shows that our organization is very active in the radio astronomy academic side of the equation. What else has been going on? There was an X flare, I think an X5 on the 31st of December. And there's been a lot of talking about data quality in terms of what does everybody do with all their historic data, and how do we know what the quality of that data is, et cetera, on listserv. So there's a lot of comments on that. Okay, let's see. Let me go through the guys that are later in the time zones here. Wolfgang, congratulations again on your great article. And what else you got to update?
Yeah, thanks very much for the encouraging and nice comments I had on our publication. Of course, that's not just us. It's been a cooperation between essentially several universities and 4 instruments altogether, all in the 25 meter to 30 meter range. It was fun doing it, and well, it took quite a while also to have it published. As usual with scientific publications, go through several review cycles and so on. But we are glad that we could get it out this early January. And we're not stopping there. We have another FRB article in the process for a next round of observation on a different FRB. Probably will. We don't have a draft yet, so it will be quite a while until we can get it out. It's the same team, same 4 telescopes. As far as some more recent observations concerned, maybe it's worth mentioning on the 13th of December, we had in our area an occultation of the galactic center region by the moon. So what happens there is, if you look towards the galactic center region, essentially what you see is continuum radiation coming from what is called Sagittarius A West and Sagittarius A East, which are 2 continuum sources. One, I believe, is a star forming. One of the areas is a star forming region. The other thing is, I believe, a supernova remnant. And what happens is the moon comes in and covers these regions, so the continuum radiation drops, and then it comes back again once the moon gets out of the way. I don't have any slides on that yet. Reason is that there will be a second of this type of event on the 6th of February, I think, 6th or 9th. And we'll do a recording of, yeah, it's on the 6th, I just checked. We'll do a recording of that, and then I'll prepare a couple of slides. That's something that I was thinking about whether that can be done with a 3-meter dish as well. Probably not, because in at least in our area, you have to go very low with your telescope because the galactic center comes only slightly above the horizon. And then you get a lot of thermal noise from the ground. And of course, in other regions of the world, this simply doesn't happen, just like a solar eclipse does only happen locally. So it's a more European event that you have. But we did actually do a simultaneous observation of that event in December with our people, or with the people in Dwingelo in the Netherlands, which also have a 25-meter dish. And we're in the process of comparing those. So that was kind of interesting. So we're hoping to repeat that on the 6th of February, and then on the next occasion, I can report more details on that.
All right, great. Anybody got any questions for Wolfgang? All right. Our Australia contingent, Robert.
Oh, Happy New Year, everybody. Can you hear me?
Hear you loud and clear.
Oh, that's good. Well, basically what's happened is I haven't done any observations recently because I've, torn up the backyard and put in a carport, to house my car. And but what I have done is, 2 things. One, I've made a reservation at the Hilton in Dallas for the for the total eclipse and the conference, and done some initial what to do for a total eclipse for people taking pictures and that type of thing. I haven't booked any flights yet. That's easy to do. But anyway, if anybody needs any information about, how to take pictures and stuff, let me know. And oh, there's an interesting picture. Okay. Anyway, and the second thing is, I've started the installation of a second telescope. It's not at my location. It's up in what we call the Blue Mountains here, and it's probably 20 miles away from where I'm at, and I'm helping a friend install the radio telescope on his property, and hopefully get that up and running in the next couple of weeks, maybe a month or so. But anyway, so that's basically it for me. No observations to report right now.
Oh, great. And for anybody who doesn't know, Robert travels the world and does eclipses. So he's talk to him if you have never seen an eclipse or want experience with it. Let's see. Marcus, thank you for coming on.
Yeah, I've been just furiously busy the last several months, and that isn't going to stop anytime soon. But I thought I'd drop in and say hi, and let you know what's going on at the observatory. We're feverishly trying to meet a kind of a soft deadline date of the first week of February to get the dish tracking again, after it not doing so for almost 30 years. We have new motors. I've written the initial control software, but we're waiting on mechanical interface stuff. And like a lot of other little things, like the cable management system needed to be stripped of all the original cables and hoses and cooling lines and all of that. And we have to repopulate the cable management system with the cables that are, important to us. That's a singularly unpleasant task. Let me tell you, it's like, I don't know if any of you have watched the movie Matilda back in the day, but in Matilda, there was this cupboard where students were punished called the chokey. And we actually have named the cable management chamber of the chokey because it's really unpleasant in there. It's, particularly for an old guy like me, it's you can't even stand up, and it's confined quarters, and there's all kinds of stuff in there that either wants to rip your head off or rip your abdomen open. So it's just not that much fun in there. So that's part of it as well. I'm giving Princeton, who is kind of the driving customer of this, if you will, about a 60% probability that we'll be able to meet the deadline. And they seem happy with that. They're actually currently paying me to manage the project. So, that's kind of nice. In terms of observations, we haven't been doing much in the last several months because it's all been about, the mechanicals and getting the thing going again. But Dan Marlowe has been trying to do observations of a pulsar in the southern sky without much success, which we suspect is just a pointing issue. Again, like we have so many things that all need to be addressed in parallel, and we're trying to maybe do a few observations as well. But the other day, he got an anomalous recording, which is very likely RFI, but it also could be an FRB. He's still doing the data analysis on that to see if maybe we captured a random FRB while we were looking for something else. It seems unlikely, but you never know. And that's about it. I mean, we're really busy just getting the thing working again. We did do some observations last summer, like all of the usual suspects, like M87 and Cygnus A and 3C400 and 3C273 and all of those things that you kind of do to to sort of fill out your bingo card. But we haven't really done much since then. We've just been really busy with, well, with structural issues as well. We had a structural issue we had to deal with before we even moved the telescope again. That was dealt with a few weeks back, and all seems to be in good shape. And we only had to spend about $2,000 fixing that one, so that's actually pretty cheap given what we ended up having to do.
All right, Jamison's got a question.
Hi, thanks. I didn't catch where your observatory is.
Oh, thanks. It's in just outside of Ottawa, Ontario, Canada.
Okay, thanks.
In a little town called Carp.
Yeah, we got a lot of new members on right now. And could you give a quick overview of your observatory and what you do there?
Who, me or Jamison?
Marcus.
Oh,
Yeah.
okay. Sorry. I guess most of the people on the list know me and what I'm up to. We have operated various observatories over the last 6 years. I run an organization called the Canadian Centre for Experimental Radio Astronomy, and it's mostly amateur based, although we do have some professionals who are sort of on our advisory team. Currently, we're restoring a former NATO satellite dish for radio astronomy use. It hasn't actually been used for anything in almost 30 years. It's 12.6 meters. It's elevation over azimuth. The dish weighs about 5.6 tons. The surface is good to, I suspect if we wanted to, we could do 30 gigahertz observing. We'd have to get some better encoders, but we could probably do it. We're a little bit radome limited, but the radome is actually still reasonably transparent, even up at 30 gigs. We currently have a 21 centimeter feed on it, and there's a small team of us restoring it for use for mostly radio astronomy, but we also have some interest from the lunar space mission community as well. So we may end up being, dual purpose at some point.
All right. And for the new members, we're going to put a lot of this stuff on chat. So if, I don't know, Ted, if you can, or Marcus, you could put your the website for your observatory on chat.
Yeah, I'll do that.
We got a lot of new people who don't have a clue what's going on because they've never been on the SARA websites or anything before. So pretend like everything's new and just keep putting a bunch of stuff on chat.
Sure.
And for people that new people, excuse me, if you can go to the chat section on the Zoom, we're going to put a lot of stuff on chat, and the goal is to go ahead and copy that before we sign off. Because a lot of that will go away as soon as I log off. Okay. Let's see. Edward. Edward's is one of our maser experts.
Hello.
Hello.
Can you hear me?
Yep.
So, shall I introduce myself or?
Go ahead and then tell us what you're doing and some of your equipment and everything.
Yes. So, hi everyone. I'm Eduard. I'm a geosciences student from the Netherlands who does a fair bit of radio astronomy in the spare time because I have a lot of interests. And the thing that I particularly like to do is to work on the detection of masers. So for that, I'm currently using a fairly small 1 meter dish. It's currently actually outside in the cold doing an observation of a maser source. Yeah, that's it.
Okay, what's the latest maser you've got? You got any slides or anything about what you've just done, or?
Yeah, well, currently I'm
putting you on the spot.
I do have some recent observations, but unfortunately I'm now on my phone, so I don't have some slides or anything to show. But
Okay.
For the next radio telescope observation party, I can show you something.
All right. Hey, glad to have you here. Thank you.
I've got just one question. What is a maser?
Yes, that's an excellent question. So a maser is essentially the microwave equivalent of a laser. So it's essentially like it emits coherent microwaves at a very specific frequency. And the crazy thing about these things is that they actually occur naturally in outer space in places like star-forming regions or in the atmosphere of red giant stars.
So isn't the basics, and you guys correct me on this, but the basics is that you've got basically a cloud of some kind of a gas, and you've got a star that's behind it and sort of in relationship to us. And then when the energy from the star hits that cloud, it causes excitations and avalanches, just like a laser does, but it's in the microwave frequencies, and it causes an amazing effect that we can see. So we're really the star is causing the lasing through the this material, and we could see that. Is that about right?
Yeah, essentially, yes, that's what it is. So yeah, essentially, if you have like a cloud of gas with, for example, water molecules are one of the type of molecules that can do this, and they're being excited into a higher energy state. If you have then some incident photons coming in of exactly the right amount of energy, they can trigger these excited water molecules to fall back to lower energy levels. And when this happens, the excess energy is emitted as an extra photon. So you're amplifying these photons, you're amplifying radiation along this cloud. And that's when we see a maser. So we see a very strong amplified radiation at a very specific frequency when we look towards these clouds.
And they're relatively bright because you're getting them with a 1 meter dish. At what frequency? For the water
yeah, so currently I'm working at 22.2 gigahertz, and this is the frequency of the water masers. So this is essentially one of the spectral lines of water at which maser emission can occur.
All right. That answer your question?
Absolutely, thank you.
Yeah, and we got a lot more in the Edwards put and Wolfgang, everybody's put a bunch of maser articles in our journal, and we got a couple of YouTube videos on it too. So go ahead and check those out. Let's see. Let me see if I can go to the next guy here. Ted, how is ezRA and all your observation team you've been putting together? Not hearing you, Ted. Okay, Ted, I think you're still muted, even though you show unmuted. So I'm going to go to the next.
Little plugged in, maybe that works.
There you go.
Yeah, that makes some sense. Testing is appropriate. All right, let's see if I can share anyway. Let's see. We push that button. Maybe you see the pretty blue ezRA.
There you go.
Anyway, I keep enhancing ezRA and putting new plots in it. I'm studying, even with some help from Nathan Butts online, trying to figure out if we have a whole bunch of data, how do we get all that RFI spikes out of it? So I'm making big progress on that. And Nathan, I have to bring you up to date too. Put some new software up. And so ezRA keeps going even through the Christmas season. But mostly I've been playing more with hardware. Last time I showed you a picture like this of a bunch of metal discs in a disc Yagi. In the plastic bag is the LNA and then off to a coax. and pointing up at the sky. Okay, that works well. Then I made 2 of them. I put them on a board like so, pointing out into space. And if I had the board, let's put 2 of them on it, as I say. This is about 2 meters apart. And I was showing some experiments with that. But now what I've done is moved them really close to each other. This is not so much an interferometer, but more really an antenna array. Is there a way we could make a cheap antenna that points at a small part of the sky, has a small beam width? And so I'm just experimenting with that. The experiments will go on for a long time, but we begin. If I put these 2 antennas real close to each other at 240 millimeters, I get some kind of pattern across the sky like this. Over on the left, you can see a bump of energy. If we study that and put a line halfway up and then study how much time that is between where it's above the line, it seems to be about 45 minutes. And I don't fully believe it, but that would translate to about 11 degrees beam width, which is actually pretty small for such a tiny antenna. Do I believe it yet? I don't know. Maybe I have noise that's bouncing around more and confusing my data. So we'll see. But those are the experiments I'm playing with, just to see what we could do with cheap hardware. Any questions? Very good. Back to you, Rich.
Okay.
Yeah. Real quick, Ted, what was that half power beam width you ended up calculating? 11 something?
There's the math,
11.25
on the sun. I suppose you subtract half a degree, but I'm not sure I fully believe it yet. I'd like to get a smoother Gaussian curve from measuring the sun. And it could be that I'm getting confused by, well, but I'm measuring at 1423 megahertz. And so I don't think hydrogen really is getting involved. It may just be things are weak. I don't know. But instead of something like 30 degrees for a beam width, I'm getting 11, maybe. I got to prove that.
Okay. Trying to get a couple of other things squared away, and then I was going to try and replicate your Yagi style there. And if it's at 240 millimeter, maybe I can try the same experiment here and see if we can't confirm results.
It was fun to do it at 2 meters because then you actually get some kind of fringe pattern going on.
Mm-hmm.
Back to Rich.
All right. And Ted, for the new people, give a quick overview of how they can get ezRA. And
there at the bottom of the page is the website. It's got my name on it and ezRA. If you look up Ted Cline and Astronomy, Google now lists me as well. So many possibilities. I encourage folks to look at the first 2 videos on that web page. Listed on that web page, and that kind of gives you a flavor of what's going on. And then it continues and continues in a learning experience all the way through the shape of the galactic arms and where they are in space, and then perhaps what about the thickness of the galactic arms? Where are they 3-dimensionally in galactic space? Done with free software. Give it a try.
all right.
And I've done you a favor and plunked your link in the chat for anyone who wants to go for it. You're welcome.
Thanks, Joe. Highly recommended, everybody. If you haven't done hydrogen yet, this is a good place to start. Okay, Alex.
Gotta get out of here. There we go.
Perfect transition. Last month's presentation was.
All right, you very bad audio.
Bad?
say a few words.
1, 2, 3. How's the audio?
Okay, just went on good now.
All right, it's my internet connection. They're pulling fiber through, so maybe these disconnections will go away in the next few months. As a carryover from last month's, and actually a follow-on to what Ted just discussed, there were conversations on these disk Yagis. And I posted a note on the Sarah group, and I got some feedback, and I've been working on this project for the past several weeks. So I have a bit of a PowerPoint that I'd like to share with you. You might find interesting. Are we there? Do you see it?
You got it.
Okay, so this is my my effort into doing some research and developing a circular patch Yagi. As I said, I posted both Ted Wolfgang and Bob Strickland commented that they had these types of antennas, so it spurred my interest into taking a more detailed look at it. And let's see. Okay, one of the replies was from F1EHN, JJ Mantois, and he had provided some information and links on this long 25 element, 21 centimeter disk Yagi. And I did some research and I found information on how it was fabricated. I developed a model. This is the first time I've really done models with this level of detail. What I wanted to see was if there was a way of getting rid of this back radiation panel. So I developed a whole, many different models, probably a couple dozen of different variations on this to see if there was a way to reduce this, what would be ground noise pickup. A lot of flavors to this. I probably spent nearly 2 weeks on this, at least a week and a half, because first of all, I had never done these cylinders and discs before. So it was a learning process to developing the technique besides doing the analysis. So from there, I did some fabrication. The process was to build a 2/3 of that 25 segment antenna. The problem being when you get out to 2 meters long, it becomes structurally soft. It sags. So what I built was 2/3 of that, 16 elements long, about 5 feet, 1.3 meters. So fabricated this, and rather than using a threaded rod, a threaded steel rod, which is very heavy, I used a heavy wall 10 millimeter, 3/8 inch aluminum as the center, and the sleeves were 12 millimeter, half inch heavy wall aluminum for the spacers. And this was the main element. This is the circular patch to the reflector. Took a while to get tweaked, but I got this thing tuned right on 1420, and it has a return loss of, well, this one is like almost minus 48 dB, right on the money. And so I nailed that, and then as you started to add these elements, it started to detune, and so I had to do some tweaking on these spacings and these discs to maintain a reasonably tuned system. This is what I mounted this on this small, I bought a small $130 Explore Scientific equatorial mount to be able to mount this whole thing, and so that's what the feed looks like. It's a chassis mount feed through SMA connector to the patch, screwed to the patch. This is what it looks like outside. I've only run a few tests on this. I've only had this out 3 times with 2 variations, so I don't have a whole lot of data, but it works pretty well. It splits in half, so it's easy to carry, and it's lightweight. Now I'll show you some of the data, some of the initial data. Part of the problem was when I was building this up, according to this data, I had a problem. The first director showed that it was supposed to be spaced 100 millimeters from the patch. If you did that, it sucked all the power out of the patch. The thing was flatlined. It totally detuned the system. I exchanged a couple emails with JJ, and he wasn't sure where this information came from. There's some discrepancies here on that. This says the boom is 14 millimeters in diameter. He was saying the one he has is 12. And so I really never got a definition of if this is actually the way his was built. But I based my system on this, but I modified it in order to allow the patch to be tuned. And so the way it worked was instead of 100, it was 32 millimeters. And I got a reasonably well-tuned system. About 24 dB loss, pretty close to 1420, close enough for practical purposes to do some experimentation. So I took it out into the field and I ran some tests, compared this to my 1 meter umbrella antenna. It's a little bit better. I mean, it's a very small area. I wouldn't expect a really strong signal, but this appeared to be pretty promising. The problem was the beam width was huge. I did a sun drift, and I wound up with calculating a beam width of nearly 54 degrees. Thought, well, maybe that was based on the fact that I changed the spacing parameters. So, went back. Initially, I measured Earth to cold sky, about 4.9 degrees, and the peak of the sun to cold sky at 3.9. Then I replaced the spacers to go back to the way it was defined in that initial list of 100 millimeters, and I wound up with this. Really bad, because it was detuned. But I wanted to see if I could get a better, a narrower beam width. I couldn't. The resolution, the amplitude of the sun versus the background was so low, I could barely detect anything. I haven't plotted it, but I can guarantee the beam width is no better. And so there are issues with this. The Earth to sky is very low, and the sun was a very small amplitude also. So I went back to the websites, and I started looking at all this stuff. And every patch antenna you see out there, the first element is very closely spaced to the driven element. This one wasn't. And so I couldn't understand why this was. Went through a lot of searching. And only a couple days ago, I happened to find this guy, Dr. Wiedmar, not Jazz, Wiedmar. He's over in Slovenia. And he had done a really nice detailed model and had built these patch antennas, one for 1.3 gig, 2.4, and a higher frequency, not sure what. But this is the one that interested me because it was so close to the hydrogen frequency. I exchanged a couple emails with him over the past few days, and I sent him in emails that corresponded to this. And it says, his email reply is, yeah, these usually have a director spacing of between 0.1 and 0.4 lambda, and your design of 100 millimeters looks wrong. So I don't know what the story is with this, but I'm setting this aside as being an issue here, and going back to something like this. He made some recommendations. He has a lot of information posted, and the other thing is the 25 element Yagi has spacings of 80 millimeters. This would equate to 40 millimeters on 21 centimeters. So I'm in the process of doing some rework. He sent me a NEC model. This is what his antenna looks like through the model, and this was actually some field testing. And it is narrower. It's not 54 degrees. So I'm in the process of rebuilding this. This man has some really interesting information. I recommend you take a look at some of his websites here. He is a doctor. He works at the university. I can't pronounce this over in Slovenia, and he serves the head of radiation of optics laboratory. And he has a number of papers online. I'm very pleased that I got a number of emails from him. So that's the progress over the past month. The amplitude is reasonable. It's very lightweight. If I can't get the beam width below 50 degrees, it still makes a really great portable system as a takeout to the field and show and tell.
All right, questions for Alex?
Maybe I have a comment, Alex. We do have one of these antennas that are designed by our French friends. I do not recall from the top of my head what the spacing is from the first elements, but I would be surprised it was something like 100 millimeters. I do have also the construction details, so I could look it up. I don't have it right with me. We haven't done much with this antenna. It's sitting in our lab, but we didn't find the time to do a detailed investigation of that. But I'll contact you and see what information we have about the French design. And
I would appreciate that.
Maybe the information that you got, something is missing there. But we do have really the detailed construction, and I can check what the spacing of the first elements was.
Okay. Like I said, I have a great NEC model now, and so it's pretty easy. I've gotten expertise in making little coins on my lathe, and so I'm going to build I'm going to stay at the 6 foot. That is somewhat structurally sound, or it's actually 5 feet, and I'm going to build that with a 50 millimeter spacing and go 25 of these just to see. And I can swap it back and forth until I haven't destroyed or modified it from the original, so I can switch back between these systems from one test to another. It's interesting, if I could get the beam width down, it doesn't have the amplitude. It's a small diameter system. But as far as ease of portability, it's not easy to build. The umbrella antenna is a much easier build, but it's an interesting antenna, and would be worth having it to be able to take out to like the ham radio club and stuff like that. Yeah, I appreciate that, Wolfgang. Thank you. Oh, and I'll post those couple links.
I have a couple of subjects to chat about. First of all, what do we call this thing? For some of the spacecraft, they had a disc Yagi like this, but they called it a cigar antenna because it's big and long. But they had different kinds of feeds down at the bottom of it. One of them was a kind of cake pan like you're using. Another one was a plate, and then there were other methods down at the bottom. And I wonder if that bottom part is what actually gives the name to the antenna. Maybe it's a cigar antenna, but it has a dipole for a feed, and I've seen disc Yagi, which I think is the best description of it. And here we're calling it a patch antenna, perhaps because of the feed. I'm curious what folks think about this. What words should we be using for all this? Alex, you first.
Well, I'd say any of the above. And if you go out to the second link from Dr. Vidmar, he calls it a cigar. And so the second link I posted there provides information in that. And in fact, he has history on that. And so there's a lot of information that he has posted. And so he calls it a cigar, but it's a circular patch feed. So any of the above.
Yeah, I would agree to that. I mean, Ted, you have described it, I think, nicely. It's typically the design is that the excitation element is a patch antenna, so that's why it's called a patch Yagi in many cases. But then the directors are disks, so some people call it a disk Yagi. I think every one of those descriptions is a valid description.
Well, very good. So at least I'm not violating rules yet. Good. My interest in it was this is something that could be shipped. And so I'm kind of thinking of scope in a box replacement. I'm thinking this could be cheaper and a quick way to get folks into it. Price is perhaps an impediment for some folks wanting to explore this. You could think of the dongle, the SDR dongle receiver as a investment. The LNA, yeah, maybe. The coax, okay. But the antenna is probably viewed as temporary. How much money do I want to put into an antenna? How much and let's just lower the overall cost. If we could ship out little discs in an envelope, if we could give a sheet of instructions about how to space them on an all thread, maybe we put in little tubes for spacers, that would make life a lot easier. And so I'm always interested how you're going to attach the driven element at the feed point, just to make it simple and easy to construct. That's my general pointing on this. Wouldn't it be fun to have more folks get involved because of a cheap antenna?
The discs aren't easy to cut, not in quantity.
I found a nice way to scratch them. So I have a circle, and then I use those big scissor shears to cut the aluminum. So I'm not fully convinced of that.
Okay.
And if it is something we want to move on with, I have a localish supplier I use for one of my businesses, for where I work at, with water jet and 2D laser cutting capability, and he's very, very reasonable. So
that would work.
Yeah, you could send him. We could just buy patches of we just buy sheets of aluminum at whatever thickness, and he'd cut them right down to the nanometer, just about.
Exactly, and that's the right way to do quantity. Again, Alex, how did you actually connect that center contact of the coax onto the second disc? It looked like a little screw or something almost.
Yeah. So I used one of these, a chassis mount.
Okay, so we see a SMA connector there.
SMA, but what I did, see, this is actually, there's only about 7 millimeter spacing between the reflector and the patch. I mean, I cut most of the Teflon down with a X-Acto knife, then I oversleeved that with a brass tube that was internally tapped to a 440 screw. And I match drilled all this junk so that when I soldered that sleeve onto this center pin, it went onto the reflector, and it perfectly matched it perfectly aligned with the patch so that it's threaded together. It's a little bit of precision work. It's
But that SMA connector with all its threading and stuff could be assembled and just included in the kit. So we could do the work, and they could simply provide the screw through the second element right into that threaded part.
Yeah. I mean, I don't know how critical this is to performance, but for me to align it to attain that level of accuracy was sub-millimeter spacing on the reflector. I have, on the patch, I have 3 screws with nylon standoffs. And I sanded them to approximately the right depth, and by tightening or loosening the screws, I could shift this thing fractions of a millimeter to get that right to get to 1440. I don't know I don't know how practical that is and how significant it is to the performance. But I have built 3 patch antennas now, and they all are extraordinarily critical in that reflectors to feed spacing.
Well, I wonder about required accuracy or precision. We use a 2.4 gigahertz grid antenna off the web for the scope in the box for 1420. So, we're not exactly perfectly tuned, and we were amazed how well it does. I'm kind of amazed how well it does when I just get within a millimeter of my measurements for my this disk Yagi. And so I wonder if it would be good enough to at least see hydrogen and get people excited. And then
a millimeter off, and that's spacing you down, probably down to 1300 megahertz. I mean, it's huge.
Yeah, okay, well, versus 2.4 gigahertz. So I think you could still see hydrogen even if it was that far off tuned. I appreciate the precision you're doing, but I wonder if it's fully required.
It could also be, you start with, when I started with my first antenna, it was pretty nasty and lots of things falling apart, and I just kept making it better and better. So it gave me something to do to keep working on the antenna and learn how to make improvements to it. What works, what doesn't.
There still could be significant spillover. I haven't evaluated that. I mean,
Okay.
I haven't evaluated it.
I'm fascinated by your construction technique. Thank you very much. And doing all the research and data collecting. Excellent.
Okay, we have a new member, David, had a question about the disk thickness, if that influences performance. And
No, I mean, I used this 1.5 millimeter, 16th inch. I just had this. I've got a garage full of stuff. I mean, it needs to maintain its rigidity. I wouldn't try to use, PyEphem, aluminum PyEphem material, but it doesn't need to be this rigid.
I just used some thin aluminum that I had. I haven't measured it, or do I really care at this point?
Alex, this is Doug. I want to make sure you can hear me.
okay, we can hear you.
Okay, so I've been doing some experimenting. I do a lot of 3D printing, and there are filaments out now that are metallic. And so I'm testing some that are iron and other different materials infused to see what the reflective ability is. The thought that occurred to me hearing this was if you come up with the exact size of the disk, you can actually use the 3D printer to print a disk that's not 100% metal, but reflective. And in the building of it, you can include a collar on it with a pre-threaded hole for a nylon set screw. So you technically could take your disk and slide them up and down your boom, and you could change the adjustment without a whole lot of problem. Plus, if you were trying to do a kit, that would make it really easy to put together. But I'm having to upgrade my 3D printers to do 300-degree hot end heads so that I can use the metallic filament in the printers.
Is the metallic material electrically conductive?
Some of them are stainless steel infused, some are copper infused, some of them are iron core.
If you measure, take resistance across it, is it 0 ohms?
Well, it's not 0, but it's something less than 0. I mean, more than 0.
But is it hundreds of ohms or 5 or 10? I mean, you can physically. It's not just like a powder separated by non-conductive material. It does have a distributed conductivity. And
the answer is they're all different. They're not the same. It depends upon what they're infused.
It needs to be electrically conductive across the surface.
Yeah.
Not just optically reflective, as I found with the photo umbrellas reflectors.
So I would have to print some and check them. But that's just a thought because they're getting better and better with this stuff.
Is that electrically conductive on both sides? I mean, if we just coated one side with aluminum foil, and does it matter which side, or both have to be it?
Look, I think it has to be uniformly conductive. This is, I'll have to look it up. That website has information on slow wave. I got to look it up. It's SWS, slow wave system, and it's a wave propagation antenna. I'm not sure, but I think it really needs to be a metallic conductive material.
All right.
We have been experimenting a bit with structures 3D printed and then doing a conductive material on it. We haven't come to a conclusion. I do remember there was a report from guys who did a feed or a kind of feed horn for higher frequencies, which was manufactured from a 3D printed part, and then it was covered by some conductive spray type of thing. And what they found is that the surface roughness was one of the areas which they had to deal with in order to get a good performance of that feed horn. I cannot report yet on any results from our side. What we have done is we have 3D printed a 6 gigahertz feed horn and sprayed it with essentially a copper-based spray, which is conductive. We found that the DC resistance is fairly low, but we don't have any RF performance data yet. So we're working on that. Not sure whether it's going to work out in the end. Having said that, if you think about doing a disk Yagi, I would assume that possibly doing a 3D printed disk and then covering it with this kind of copper spray, that might work, but it may, then in this case, it may be even easier to get just as a PC board and cut circles from a PC board, which has a thin layer of copper.
Let me share one screen for 15 seconds, if I can.
Wolfgang, what was that dish? What frequency? You said 60.
The feed horn that I was... I'm sorry. The feed horn that we were making was for 6 gigahertz. That's a 3D printed Kumar type of feed horn. We 3D printed it and we covered it with a copper spray. As I said, I don't have any RF data on it yet. It's still in the making. We found that the DC resistance is fairly low, but yeah, we're just experimenting with it.
Let's show this to you. This is worth reading. It's called Slow Wave Structures. And I really haven't read it, but included in this is the disk Yagi.
Hey, Alex, you put the link to that? We just sort of saw it for a few seconds.
I think I got kicked offline.
You're back.
Did you see that web page?
Yeah, just for a few seconds though.
All right, well, hold on. We'll try to make it a couple more seconds. I just got this morning. I've only exchanged emails over the past day and a half. This is called Slow Wave Structures, something I've never heard before. There's a little bit of history about this, starting in the late 1800s. Got to look through this, and part of this is these metal discs. So this is all brand new to me. I've never heard of this, but it's described. I would think they need to be somehow fairly conductive.
All right, put the link to that in the chat if you could.
Okay.
All right, great. All right. Any other conversation on disk Yagis or patch antennas or whatever else Ted thought we could name this thing?
Just to
All right.
comment, it's Tom, just to comment on the scope in the box. There's now a hydrogen line antenna available. So it's 1420. I have one, and the student I'm working with has one. So it looks like the gain is a lot better.
You got a picture of that or description?
I think
Hang
that's the NOAA grid that you can buy on Amazon. They've started offering a 1420 boom with it.
Okay, Nathan, you say you got one too?
Well, I got the 1.7 gig for Go satellite, but then built a CAN to go in front of it. That's my 1 meter. Yep, that guy right there.
Here you go.
All right.
The head is much larger than the 1420, of course, to work at, or I should say the 2.4 gig. The 1.4 gig head's much larger, it's longer, and the gain is a lot better.
All right.
And it's on the same dish.
Did you get that on Amazon or?
Yeah, $99.
Okay.
They also
right.
have a 1.7 gig.
And what is that called? Or like, can you give me a link to it?
Yeah,
Hang on. I can find it real quick.
It's on Amazon. Just Google hydrogen line.
I think that's the same dish that I use. They are like $99. It's like 60 centimeters by 1 meter.
Yeah, it's the same dish.
Yep.
And all they did was that they went with a 1420. They're making a lot of, well, they've got the 1420 preamp, 1420 filter. So they really think they can make money off it, which is good for us.
Now, if anybody doesn't know Tom, he also actually is the arbiter for the listserv. So if you ever get kicked off, it's because he didn't like what you were saying. And also, he's the grant chairman. So could you give a quick overview of the grant program for everybody? Because we got a lot of new members.
Sure. We run a program for students and for teachers. Typically, well, we offered all of the standard ezRA labeled products, the scope in the box, the Radio Jove, which is a NASA project. So SuperSID, which is University of Stanford. We just did 3 grants, two going to India, one going to an area outside Detroit. And if a student wants to build something themselves, we'll supply either the parts or the money. Typically, we prefer to provide the parts than sending them money for obvious reasons. So we pretty much do, on average, 1 a month. Western Europe and the US participation is fairly low. Asia is fairly high. So we'd like to see more participation in Western Europe and in the States. To that end, the Gwinnett Amateur Radio Society has got something called Ham Jam this coming weekend, and the student I'm working with will be there with her project, which she is going to image the galaxy at 1420. The student last year measured the rotation of the galaxy, and she received the highest mark available on that project in school. So I guess I'm becoming a fixture in that. It's a STEM school, which is to me a vocational school on steroids. So next year we may do a comparison of the gain of the different antennas. We'll see how that works out.
All right. And so any of you who want to mentor a student who would like to get a scope in the box, a Super Sid, a Radio Jove, or a and what Tom makes is the itty bitty telescope. Contact the grant. You send it to me, but we'll end up getting it to Tom, and we'll get you one of those for your student. Okay, that's what the grant program does. Okay, so think about that if you want to mentor somebody. All right, thanks, Tom. Let's see, Peter East.
Hi. Sorry, I wasn't expecting you calling me. Yeah, I haven't done an awful lot since I submitted my paper, but I have been looking at some old data that I've had. You know, I'm working in the pulsar field with a small aperture. I've been developing my own software, mainly because the professional software, I've used that as well, but I don't know quite what algorithms they're using. So my experience has really been to develop experience in applying different algorithms to try to recover a pulsar out of noise and interference. I've tried not to blank data. We know we get interference, and I've tried with my software to find the pulsar in the interference. Using Presto, it's got a number of features that you can get rid of frequency spares and spiky noise and that sort of thing. But if you're not careful, it will always find a bit of interference rather than a small pulsar. So over the years, I've developed quite a few bits of software. I'm not a software expert like Ted Cline. I don't even know how to use GitHub. But I'm reasonably au fait with algorithms and mathematics. So I've developed a lot of things, and you know, a few of the papers that I've written have been trying to emulate Presto and emulate some of the algorithms that they use. So anyway, I've developed this software. It's not really in a state that other people can use because I'm tinkering with it all the time. But I've gone back to some of the very earliest data that I recorded in my first light. There was a bit of controversy at the time because I added up a few results that from different trials. And so I've gone back to that original data where the signal to noise ratio was very low. And what I found was that you tend to do a measurement over 3 or 4 hours and fold the whole of the data. And because of scintillation, this isn't always a good thing to do. And the fact that most of the measurements I've made have been in the drift scan mode, you get the strongest signal when your antenna is pointing directly at it, and it weakens towards the edges. And so in a 4-hour trial, with scintillation and the vector of the beam width, then the signal varies over the time with the maximum signal at the middle. And I can identify that. And probably the most useful algorithm has been one which I call a rolling average, where you take say a group of 50 or 500 or 1,000 where the content is a 500 or 1,000 rotations, then scan that over your 4 hours, and in that way you can identify the peak and that sort of thing. And you know, to cut a long story short, I know I'm going on a bit, I'm sorry about that, but what I've found is that in one of the trials, well, the only trial that I've looked at, which I took the data back in 2018, I found that if you average the whole 4 hours, you get a signal to noise ratio of about 4:1. But if you just choose an optimum region, then that goes up to 5 or 6:1. And so it's been very interesting that I've been able to do that sort of thing because I've kept the old data. But anyway, that's the sort of thing I'm playing with at the moment.
Thanks, Peter. Anybody got any questions for Peter? Yeah, he does. If anybody wants to get into pulsars, he does a single a Yagi pulsar, and then you get 053. I forget the thing is. What's the pulsar you can get with your system?
B0329.
Okay, and that's pulsar most people can get with a.
It's the strongest pulsar in the northern hemisphere. Yeah.
Right. Okay. Let's see, Preston.
I don't really have anything today, but I really enjoyed the discussions that I've heard.
All right, thanks. Helen. I'm just going down the list now, so.
Not a whole lot. We got the flu for Christmas, so nobody's really done much of anything. But I was happy to hear about Dr. Cline's ezRA. I don't know why I hadn't looked at it before, but that'll be my project before we meet next time. Thank you.
I have a few comments for you, Rich. If I can
go ahead, Bob.
Before people get away, I wanted to say a few things about the Western Conference, or my thoughts on that. I want to share my screen if I could.
Go ahead. And you're a little light on sound there.
Okay,
I'll get close to the mic.
I think I'm sharing now. Is that right?
Yes.
And this is a map of the Dallas area, and I think my mouse is showing up on it, but the location of the conference is going to be at the University of Texas at Dallas. And it's in Richardson and Plano area. It's also referred to as the Dallas proper, but it's sort of right in this area. And one of my concerns is how many people or if people are going to want to go off and be right on the line of the eclipse. And so I've spent some time, looking at this and thinking about different possibilities. But for instance, in this case here, if you jumped in a car and drove there, this is all in the city, so with more traffic, but freeways. And then you get on this road here, it's like a freeway, and it gets out into the country, and there's a lake there. So I'm thinking about whether or not I should drive over to this area and look it over. because one of the things that might be needed is a place where you could stay and maybe find a restroom close by and things like that. But then we also have a logistical thing in that the conference is only 2 days, and this is probably an hour and a half, maybe 2 hours if you plan some time to set up. If you want to take antennas or camera equipment or whatever it is you're going to try to observe with. And this may be adequate because we're in this band, so to speak. And in some cases, I understand from talking to Robert that maybe some people might not want to be right on the center. You may want to be on the edge. But the logistics of all this are going to become an issue potentially because some people are going to want to wander off and go be there, I'm thinking. He mentioned one of the concerns is weather. And we do have storms that blow through in that time of year, but the eclipse is mainly during the middle of the day. So that bodes well for avoiding storms because they typically happen late in the afternoon and early in the morning. And it's also possible to consider the weather and instead of going to this location, drive south or move to a certain location that's away from the weather. But I wanted to just bring this up and maybe we'll talk about it some more offline, different people decide what's going to be best. But I want to encourage you, if you're thinking about coming, to make your hotel reservations. And I think that information was published in the journal. Is that right? I didn't get to see that, Rich, when it finally came out. I haven't looked at it yet. But if not, we can get that link for the hotel. And it's a really good rate. And unfortunately, most of the hotels in this area are increasing their rate because of the eclipse by 3x what this rate is. So if you wanted to come to this conference and see the eclipse, it's going to be a great opportunity for you to do that. And that's the main thing I wanted to talk about.
Great. Any questions? Bob's going to be our local rep for the conference down there. So he lives down there. So any questions about the Dallas trip or anything?
I have one. Yes. Where did you get the map with the eclipse lines on it? Could you send a link? Could you post a link for that?
I'll try to find the link, Preston. I just found it on the web. It could be off, and it could change, I suppose, slightly, but
okay.
I found that on the web.
Okay, thank you.
There's several places I noticed that have maps, but not very many of them are really detailed with an exact line on it.
Okay.
Hello?
Go ahead, Robert.
There are two places where you can, Xavier Xavier from France, he has do a Google search for the interactive solar eclipse maps. And, and the other is Michael Zeiler in Santa Fe, New Mexico. He does the Great American Eclipse maps. I can put the links for both of those on the chat for you.
That'll probably be better links than I would find, so that'd be great.
Great, excellent. All right, any more questions about the eclipse and the Dallas trip? All right, good stuff. Let's see. Mike Ott. There, Mike?
You're muted, Mike.
Okay. I don't have anything to present. I've been experimenting with that AD 8302. I'm pretty excited about that as the interferometer detector. It's been working good. I've been playing with op amps and trying to improve the signal. And I may have more information for the next for an article. So we'll see. That's it.
All right. Got any questions for Mike? Okay. DDecker. I don't know your first name.
Yeah, hey, this is Rich. This is Doug Decker, first name. Kilowatt 5 Whiskey, Mike Tango, White Mousetrap. Anyway, yeah, I got started in this a couple of years ago, right after I retired, and have gotten a lot of help from Ted and from Alex and a few others trying to figure out how to make hydrogen line stuff working. And so now I have my little chicken coop 1 meter dish sitting out in the back in the wife's vegetable garden, and I'm pulling down some really good straight up overhead stuff, have been now for about 3 or 4 months in a row. So one of the things I'm trying to figure out how to do is take all that data and decode it or decompile it or whatever you want to call it, so that I can start comparing like one day to the next and then a group of days to another group of days and look for the variations. Just trying to help figure out, you know, how good the system really is at collecting the data. Not that I know what to do with it yet. Also originally, because of some work with ham radio, wanted to try to do a helix antenna, ran into some problems. I've since then discovered a guy who makes the trusses that hold the wire up, and you can make them with a 3D printer. So I'm getting ready to do that, because you can get a fairly decent amount of gain in a fairly small area, which living inside a city, urban, suburban area, you know, everything you can keep small helps keep the HOA off you, you know, which is, I don't have the luxury of living out in the country. But working on that, I'm getting ready to have back surgery, so I'll be out of commission for about 6 months. But I'm going to continue to do as much as I can here on the PC, working with the data, you know, working with Ted. I did order a low pass filter, bandpass filter, and a preamp for 6 meters. And I built that turnstile quad and doing some meteorite monitoring. And it seems to be working well. The biggest problem is its gain's a little low compared to people who use beam antennas. But then in my mind, the beam antenna only lets you view stuff, but mainly coming off the front side of the beam, whereas the omnidirectional antenna lets you catch stuff off of all sides, depending upon what frequency you're using. So I'm going to increase the gain on it. I've got that up and running, and I'm getting ready to try to put up like a super SID type thing. I may not order one. I just may build one from scratch. I got lots of spare computers around here. I just got to find one with the right sound port in it. But other than that, that's about it. I'm retired and staying busier than I was when I was not retired.
All right, we had a question from Jamison about on the chat about what you are using to get to store your data and your SDR type.
Okay, so briefly, what I've got set up here at the house is I've got 2 dedicated PCs, one running for hydrogen line, and it's on my internal network in my house. And I've got a network attached storage unit. And as I collect the data on the PC, I've got a program every night at midnight transfers all the data off of the collection PC to my network attached storage unit. And then I've got a big 16 core, really beefy machine here in the office. And I can then pull the data down from the NAS, and I can do a complete analysis in about 2.5 minutes on a full day's worth of data, generate all the plots that Ted's beautiful software does. And so, you know, that's it. I will comment, I was having a problem with the distance. And so I ended up, I've got the low noise amp, I've got the SDR about 3.5 feet away. Then I've got a Ethernet extender set up out there that the Ethernet, the SDR plugs into, and then the direct variable Ethernet cable, and it runs back to the house about 200 feet away to another Ethernet extender box, and then it plugs straight in it. So some of the fun part about this, if my SDR, my LNA lock up or do something they shouldn't, I can use my home automation circuit to turn off the outlet in the wife's greenhouse that actually feeds power to this system out there, and it does a complete power reset. I don't have to get up in the middle of the night or in the rain and go run 200 feet out in the backyard in the dark and get snake bit. So
I guess I was wondering like what program you're using with the SDR to slurp data down. I use SDR Sharp.
No,
and there's a plugin.
I used SDR Sharp for a little while, and I kind of got, this is just me personally, a little frustrated with having to constantly go outside and redo the background. By the way, I developed a way to make that easier. But then the thing I started doing recently is I'm running TED software, the ezRA, and you don't have to do the background check. He's got some nifty ways in there to do it. I'm not really sure, which process or method is better. It's just using TED software makes life easier on me, not having to go outside and cover up the feed horn. And if I had the time, or y'all had the time, I could show you how I use the pie plate to fix that problem. Just verbally, I drilled a hole in the pie plate and stuck it over the rod that holds up the feed horn. And every time I wanted to do a background check, I just slid the pie plate up and
I use foil
and use the clothespin to hold it in place. And when I got through with the background check, took the clothespin off, the pie plate fell down, covered up and protected the center hub of my antenna. So it did dual purpose. So it's still there. I'm not going to take it apart to remove it. Does that help?
Yes, thank you.
Okay.
I'm interested in learning about software in particular because I also am a little frustrated with SDR Sharp for that reason, and the fact that I guess whoever wrote the plugin is incommunicado and nobody knows how to modify the plugin. I would like to maybe take a stab at it. I'm a software engineer, but I don't know if I'm fairly new to radio stuff in general. I think one feature would be nice is to have local mean sidereal time as your timestamp instead of calendar time with each of the measurements. But I have not taken that on yet.
Yeah, all the time stamping is done by TED software, and the PC is synced to WWV through the network. So time stamping is about as accurate as I need it to be.
Is that local time or local mean sidereal time?
I just happen to have a GPS clock here in the house that I pick up my NTP off my PCs for. And so the only variation in time is the delay in the NTP across the wire in the house, which is not much.
All right. Yeah, if you're a software engineer, I'd say hook up with TED.
Sure.
And I would start with ezRA. That's probably the best software for amateurs that I've ever seen right now. So, so okay. By the way, Doug, just a fun fact is I've got the same Heathkit amplifier that you've got sitting there. So just a
So since you mentioned that, Russ, I'm going to take a couple seconds. My amateur radio mentor, Hardy Prescott, who brought me up through this hobby, passed away. And before he died, he gave me his entire Heathkit S-line. So I've got 3 complete Heathkit S-lines sitting on the wall, all vacuum tube, and my retirement is rebuilding all of them.
Okay. All right, thanks. Let's see, David, K3DFD. Yeah, I don't hear you. All right, David, I'm not hearing you, so I'm going to go somebody else. Is it Detlef Wilhelm?
Yes. Hello, it's Detlef from Regensburg in Germany. Can you hear? Sorry, one moment. Hi. So I think you can see me. I'm new in this group. I think last year I visited the group for one time, but I don't have any time. For me, I'm working on hydrogen too. And I don't have many space on our roof tellers. And I think so I try to work with phase shift antennas. I have 8 patch antennas and phase shifters, and I try to form a beam to find to get a better to find more details. I'm working on this problem. Yes, maybe I can show you something like an overview.
Go ahead.
One moment. It takes a bit of time. Sorry, where is it? I think here it is. Can you see it? Hello?
Yeah, we do.
I think I try to make a phase shift antenna. I have 8 antennas. Maybe look like here. I think 8 antennas, only a reflector and the feed element. And the distance between the elements is about lambda, 1 lambda. Okay, another picture from the main electric part. I think in this box, I don't have any picture from this side. I have 4 phase shifters, a combiner, and 2 boxes. 2 boxes goes to 1 combiner here, and then goes maybe, I think, through a bandpass filter and a preamplifier. And at the back end, I use SDR, Adam Pluto, and the Raspberry Pi for the software for measurement. I think I get a few years ago, I get a program from Wolfgang to control the SDR and to make the measurements. I think analysis I make on a PC. I think, okay, the 4 phase shifters, 8 phase shifters are controlled by SPI bus, and I'm working on this problem. I have another reference channel with 50 ohm resistor and an amplifier to maybe one moment, to measure the curve from the Adam Pluto without any signal. This is, I think, this is a blue signal, and if I use antennas, I get signals like this. And I'm working on this problem, and I've tried to modify the beam by the phase shifter. This is one idea from me. I'm working on it, and maybe in 4 weeks or later, I can show you more details. Okay, thanks. Okay.
Wow, that's cool stuff. Anybody got any questions?
I really look forward to any information on that. Phase shifting is something I've been interested in for a while. So I'm really anxious to see that.
Mm-hmm. Okay, I think I take a phase shifter. I bought some, I think at eBay. You can, it's a digital phase shifter, I think 1.6 degree solution. And I buy complete modules because I couldn't make PCBs with these small chips. I couldn't solder chips like this, and so I buy complete new modules. I combine them. Okay, the problem was a bit for me. I'm not very good in programming to write a program for SPI bus to control all of them, but I think it works. And now I try to find, I try to measure the beamform of my antenna and things like this.
Gently, do you have an LNA on each of the patch antennas?
We have, as I think I can show you again. One moment.
They are at the antennas?
Yes, I have a small LNA behind the patch antenna. 8, I think 8 of them. And then I combined it. Okay, it's a bit tricky to get good and cheap LNAs. I think a few years ago you could buy good LNAs from China, but now if you buy a LNA, I think they are worse. Very, very high noise figure, and I think they write a chip number on this module, but I think inside is a different chip. I think it couldn't be the original chip. And this should be very worse due to the noise figure. But well, I have 8 good ones, and I hope they are working for a long time.
All right, great. How close are you to AstroPy?
Sorry?
How close are you to Wolfgang's AstroPy site?
Yes, I think okay, but I think Regensburg is far away from Bonn, so I make my own antenna. But Wolfgang helps me with the software to control the Raspberry Pi, to control the Adam Pluto.
Oh, okay.
Okay, thanks.
Thank you. Glad you're here. All right. Let's see, Franz.
Hi. Hi. I'm also Neil. Since August last year, I follow your website and all the people, mostly Ted and Alex, because Alex I know personally, because he is also a member of CVAS. I'm living in Florida, and I'm interested in the astrophysics world, and especially in radio astronomy for years. Before I left the Netherlands, I live now over here for 10 years. I was part of the special group of Dingerlo, and then we did the renovation of the disk over there, but only the but I had not opportunity to work with it because my movement for my work. So for now, I follow all the information on the website, especially from Ted and Alex, to build up my own system. But I have more time when I am finished my wife's greenhouse, because that had a higher priority for her, for the orchids. But I will finish that in February, and then I will work further on my system and do measurements, I hope. And I like to do all kinds of measurements. My background is I am work for Unilever multinational in research for 40 years. And my specialist is computer science, computer network, and mathematics. So I hope that I can contribute later on with the software that has developed to make it more modular for users to use the software, so that you have overviews on all the options, a sort of window structure or something like that. That is my other idea about how to use the software. But I must talk to Ted about if he is agree about that we can try to do that so that it will be more usable, easy usable for starting people. So for that.
All right. Thanks, Franz. Where are you physically located?
I'm Stanford in Florida.
Oh, you're in Florida. Okay. And by the way, radio astronomy is hard, and you will not get bored, or you'll always be challenged, because there's always something that no matter what your education is.
I know, but it will not a problem, because I'm never follow the rules. So I'm always do my own things since I am born. So
I get it. Okay, thank you. Nathan.
Hey guys. So been a busy time of year with work, so haven't had a lot of time to do a whole lot, but I am getting my next dish ready. It's the 1 meter grid antenna, kind of like what Tom was showing off earlier. I did build a CAN waveguide for that, and I've got really good results out of it. I'm just doing some fine tuning, trying to make sure it works best with between that and all the ezRA software. So I do have just a little bit of data to review. Let's see here. I'll just go to screen and then share. So I'm assuming you guys can see this now. Oops, that is not what I wanted to do. Haha, there we go. So this is, I've let it scan for about 5 days now, and I'm seeing really good power, overall power results. I'm getting a very high peak, even though it is kind of in a quieter part of the Sagittarius arm over here. especially compared to my old pyramid antenna, where it, even over Cygnus A, you know, a very active region, it had a much wider beam width. So of course, overall power wasn't nearly as good. So I am seeing some good results with that, and ready to get it pressed into service. Want to kind of focus on some of the more active regions, like Cygnus A, Cassiopeia, maybe the Crab Nebula, just to kind of look at the data, look at the detail that I'm able to get out of this antenna, because my eventual hope is to get this thing dialed in to where I can put it with tracking, so that I can start doing extra galactic sources like M33, M87, all the fun stuff like that. Want to see what I can do with a sub 1 millimeter, sub 1 meter antenna. So just kind of farting around, watching it rain, watching it be cold out there, ready for warm weather to come back, ready to go to Dallas. So I guess I should probably get cracking on that presentation for the Western Conference too. So that's just more or less what I've been doing.
Great. Any questions for Nathan? All right, good work. Let's see, Mike Salo.
Oh, sorry. See if I can get this thing button. Start figure. Yeah, I'm a new member. I think about a year ago, I built a gyrator receiver for SIDs and been playing around with that. And then finally I decided to get a super SID receiver, and it's taken a bit, but it's finally come. And I was going to play around with that. So I'm in Santa Cruz, California. And so anyway, as when I got the SID receiver, they gave me a membership to Sarah. So I just thought I would tune in and see what you guys are up to.
Great.
So that's about it.
Did you get the X Flare in December, or did you have it running?
Well, I got a bunch of them last February, I think it was, when we had a series of X Flares. And I wanted to correlate my gauge to the GEOS data. So I've been looking for a good flare, but we were out in New York visiting my daughter, and I got back on the 31st, and about 3 p.m. local time, I didn't want to run it while we were not here, and I turned it back on, and I got about the last third of it. So a little disappointing there, but I'll be ready for the next one.
All right.
Great to meet you.
Looks like it's pretty active year, so I think you'll get another chance at some more flares.
Great.
All right. Nice having you.
Thank you.
Vanessa.
Yeah, hello everybody. I don't have anything to report at the moment, and I'm preparing for exam period in Germany, so nothing new here.
All right. Well, do good on your exams.
Thank you.
Okay. Nice having you. Charles Osborne.
Haven't been up to too much. This time of year, I keep the dish pretty low since the leaves are off the trees and I can see much lower declinations. So been observing down to minus 30 degrees declination, and did get lucky in December, picked up the X 2.8 flare at 1420, just because I had the dish down at minus 22, I think it was, declination. So that was a huge flare. I haven't processed any of that out though, so I can't really show it. But yeah, just been busy with lots of projects, and the systems working behind me. I think I'm at yeah, I'm at minus 20, I think, right now, declination, doing some sun transits and stuff. So that's about it, Rich.
All right, great. And everyone, Tom is, or excuse me, Charles is the historian for the SARA. So if you got any historical videos with SARA members or past or some historic radio astronomy figures, send them to Charles, and we'll put together usually an article. All right.
Well, I did have one comment on the, I think Jamison said something about the RTL SDR stability issues. I had one comment on that. I found that mine stays very consistent. I haven't lost, the lock, or, it hasn't locked up on me very much at all. As long as I plug it directly into the computer, if I start putting cables on it, I had much more trouble with stability on the RTL SDRs. So that was a finding that as long as I plugged it directly into the port and didn't trust the cable, it was much more solid. I could run it for weeks without having it lock up on the SDR Sharp program.
Okay. All right, great, Charles. Thanks. Okay, so Tom, KD4BFQ.
Greetings. Hello, how everyone?
Hi, Tom.
So for those of you who don't know, I'm the new treasurer, and that is taking up almost all my time between that and my own work. But I thought I'd stop in and see if there's anybody here and see if there was any things that I needed to hear from that. And Rich, if sometime after you get done here and you get things put away, can you give me a phone call, please?
Sure.
Okay. And beyond that, I have nothing else unless someone has something to say to me.
All right. And Tom took over a very hard job. It's the hardest job, and Sarah is the treasurer. So thanks again. Let's see, Jamison.
Hey, so I joined Sarah, I guess, a year or two ago and never joined the meetings. But I've been trying to learn about radio stuff. My background is I'm a software engineer. I've always been interested in optical astronomy. Got into astrophotography. I'm actually president of the astronomy club at the place where I work. But living here in Maryland, we don't have the greatest skies. It's humid or hot or cold or raining or wintry mixing or something like that. So I started researching. I came across the SDR Sharp article about how to do a quick and easy hydrogen line telescope. So I bought a dish that looks sort of like the New Elect dish. I imagine the New Elect dish is pretty much a copy of what I have, which is basically one of these Wi-Fi extender dishes. Set this thing up in the yard and was able to pick up a nice little hump. Can I share screen here? I can show you sort of what I've been working with. All right. So this is my little radio telescope. It looks probably fairly familiar. I've got the low noise amplifier in that box there. It was the Sawbird H1, I think. And I've gotten pretty good results with that. I also attached a IMU to the dish because I don't have anything motorized or fancy, and I need to tilt the dish by so many degrees so I can do strip after strip of drift scans and then put them together, because I wanted to come up with a map of the Milky Way, and this is what I came up with. It's pretty crappy. It's my first attempt, but I'm trying now to do more scans and see if I can come up with something a little better the problem where I live is we have a lot of trees around us, so finding a place in the yard where I can set up the dish and get a good clear view of the sky. Being that it's winter and there are no leaves, that helps. But I'm hoping to get something where I can see more of the southern sky than what I have here. You can see that last bottom line is a little faint compared to the other lines. I think that's because I was getting a little too close to the trees. But I have gotten some decent data. I use SDR Sharp as my software to slurp down samples. And then I put them together. I've written some C code to, convert things to CSV files and then monkey around with the, so that it can work with Excel to come up with some pretty graphs that show like this is, I think this was 20 degrees declination over the course of one day. And I just wanted to see like, where the hydrogen line, was. And I can see a little red shifting and blue shifting and so on. I see a very faint hump there. That must be something that's much further away in the galaxy. That's, I guess that would be blue shifted. So I'm still, very new at this and trying to figure out, how to do this properly. I don't know anything about amplifiers, preamplifiers, or so on. I'm eager to learn from people. If you have advice, I'm all ears. And the software aspect, I think, is one of the things that I'm really interested in, because the SDR Sharp program with the IF average plugin, it works well enough for me to get results like this. But I find that the IF average plugin is a little bit of a pain in the neck to work with. You have to do the background setting before you start recording data. And, if you have a power outage or whatnot, you can't just restart your computer. You have to, do another background, setting. So I'm interested in looking at things like GNU Radio, or if something's already been written, the ezRA, ezRA thing sounds interesting. I'm going to look into that. And that's pretty much that's about me and what I'm doing. And I'm glad to meet everybody here today.
Great. Any questions for Jamison?
I'm delighted with what you've been pulling off independently. Fantastic. Let's talk by email. Sounds great.
Definitely.
And from someone who also used Excel when he first started out, you did a lot better Excel than I did. And Ted can tell you what my Excel used to look like. It was.
I've run into problems with that, though. You may know that you're limited in how many data series you can handle at one time.
All sorts of things. Yeah. So you did really. I mean, I was impressed with your Excel work.
Well, thank you.
Jamison, are you familiar with MATLAB?
I am familiar with the fact that it exists, but I have not used it. But I need to learn it. I think there's like if you're doing non-commercial, non-work stuff, there's a version, like a free version for download.
It's $150, but it's a
Oh, is it? I may have heard incorrectly, but it might be worth it if it sounds like it can do much cooler stuff.
It's a one-time license. I mean, I've used it for I don't know if you've seen some of the graphs that I put up, but that's based on MATLAB.
Oh, okay.
Yeah, MATLAB's good, but also with Python, there's the AstroPy and the Matplotlib libraries.
I'll have to get over my dislike of Python, but if you could come up with good pictures, I mean, it's worth the pain, right?
Well, it can do a lot of the same things that MATLAB is going to do. So let you graph more complicated, do the math and everything behind it too. So they're both really good options.
Cool.
I'm also using MATLAB for many years for my work before, but also I do now a lot of work what Alex is doing to try to because MATLAB has also different modules for antenna monitoring and things like that. So I try to play with it and see. And the personal version for MATLAB costs for $80 when you like to use it.
Okay. Great. You got a lot of good options there, and welcome to the software community part of this. This is great.
That left from 91.
I recognize those.
What are those toys you're playing with there, Alex?
Yeah,
what is that?
Now, someone 3D printed the save icon.
August of 92, version 3.5M. You got the whole software package, MATLAB on this, and signal processing tools on another floppy.
Been a long time since I've seen a floppy disk.
Oh yeah, no kidding. All right. Okay. Thank you. Let's see, Bob. Do you got anything else?
No, I'm all set. Thanks.
All right. Thank you. All right. Last but not least, Joseph Sandy.
How's it going? Let me see here. Will this work?
There you
I
go.
don't know if you guys can see me or not.
Looks good.
My name is Joseph Sandy. I recently started volunteering at the same observatory as Ted, and I just took one look at the radio telescopes, and I was interested. So I started talking to him about it recently in his software, and here I am. So I need to get a kit put together for my backyard. I dug a old laptop out of my drawer that's not doing anything else, so I'm going to set it up and purpose it with his software, and I think it'll be fun. I'm definitely excited to try more.
Well, it's definitely fun, and I recommend to everybody that hasn't been on listserv. I don't know if Ted, you could put the listserv link down. Get on listserv and put what you're trying to do on listserv. You got all these people are on listserv all the time, 24/7 basically, and they'll give you all sorts of advice. You show them what you did and show them your results, and they'll give you advice and what to put together and things. And it's just a good way to continuously work this. Okay. I think that's it. Did I miss anybody? Anybody else have anything else to say? All right, great. And the next is Drake's Lounge. It's on the third Sunday of the month. And the next Friday after that, and Saturday for Melbourne people, is Drake's Lounge Australia, where we get the Southern Hemisphere group talking to us. Okay. That's all we got for the RTOP. Excellent discussion today. Thank you very much.
Thank you, everybody. Nice to meet you.
Thanks, everybody.
Nice to meet you all.
Have a good afternoon.
Bye.
Have a good afternoon.